Hi everybody, myself Dr. R. Balamurugan, working as an associate professor in the Department of Electrical Electronics Engineering, K.S.Rangasamy College of Technology. I am going to discuss about the controlled converters, its working, and we are going to say about the waveforms, and also we are going to say about the applications of controlled converters. Let's we explore the slides. So the outline of my presentation includes introduction, classification of converters, in that uncontrolled converters, then controlled converters. In controlled converters, we are going to say about the single phase converters and the application of single phase converters. Let's we see the converters. So basically, the converters are classified as two types, as uncontrolled converters and controlled converters. Before going to say about the converters classification, we have to know about the working of the converters. The converters is nothing but it acts as a rectifiers for converting the AC to DC. So here, based on the devices connected in the converter circuit, the converters can be classified as uncontrolled converters, uncontrolled or phase controlled converters. So in uncontrolled converters, we are using diode as conversion device for conversion of AC to DC. In controlled converters, we are using the controlled switches like SAR, BJT, MOSFET, IGBT, GTO, etc. for converting the AC to DC. So let's we have the brief classification of controlled converters and uncontrolled converters. Uncontrolled converters, we all know that it is nothing but bridge rectifiers. Here we will be having a single phase and three phase. In that we will be having full wave and half wave rectifiers. In controlled converters, major classification is single phase and three phase rectifiers based on the supply, and based on the waveform it can be classified as full wave and half wave rectifiers, and based on the operation it can be classified as fully controlled and half controlled converters. The half controlled converters we often call it as a semi converter. So let's we see the individual converters and its working. Here you can see the half wave converter of an uncontrolled converter. A diode is connected with AC supply, and load is nothing but R load. When I am switching the supply, the positive of will make this diode to forward bias, and we'll be getting the output like this. And when negative of is given to this diode, the diode will be behave like in off state, and the output will be zero. So thus the waveform will be a pulsating one. We will be having a positive of output and negative of will be zero. It will be repeated for the consecutive cycles. This we call it as a half wave converter. So next we go for the full wave converter. So for getting the full positive off and negative off as an output, we will be going for the full wave converter. Here we will be having four types of devices. That is four diodes. It will be connected in a leg, supply is given for the first leg. First leg we will be connecting two devices, diode 1 and diode 2, and second leg we will be connecting the other two devices, diode 3 and diode 4. So for the positive of input, diode 1 and diode 4 will be turned on, and it will be forward biased. The current will be flowing from AC, and it will be flowing through diode 1, and it will be reaching the load, and again it will be reaching the diode 4, and it will be reaching the neutral. So uh, this is the positive of operation, and we'll be getting the positive of output. So once when it is reaching the zero, automatically the diode will be turned off, because the voltage will be reversed in the next off cycle. So naturally the diode will be turned off. And when the input of negative off cycle is given, the diode 1, diode 4 will be turned off, and diode 3 and diode 2 will be turned on. Again the cycle will be repeating. The output will be coming in the positive of direction, and it will be repeated for the consecutive cycles. For positive off or negative off, we'll be getting the continuous output. So when we compare with the half wave and full wave, we will be getting full wave output at the output terminals for positive cycle and also for negative cycle. This is why we are calling as full wave rectifier. Next, we will see the half wave converter, which is in controlled converter classification. So the name itself we are saying as controlled converter. Here we are using an SCR as a controlled switch. Here I am giving an input supply, which is nothing but sinusoidal supply, which is given to the SCR, and it is connected with the load. The same procedure is here is it is followed. When I am giving the positive half cycle as the input to this SCR, the SCR will be turned on with the application of gate pulse, and I will be getting the output voltage like this. This is nothing but the delay, after which the SCR will be turned on, and we often call it as an firing angle. The output will be coming like this for positive half cycle, and when the voltage reverses, the SCR will be naturally commutated, and for the negative half cycle, I will not be getting any output because the SCR is an unidirectional device and the output will be zero. Like that, the cycle will be repeated for positive half cycle and negative half cycle, output will be zero. It will be getting for continuous positive half cycles, and continuous negative half cycles will be getting zero output. So this we call it as an half wave output, and this type of converter we call it as a half wave controlled converter. So here the load is R load. Next we see the RL load. Suppose when I am connecting a L load with a series with the R load, we will be getting some negative direction output waveform. This resembles the storing of charges for the positive cycle, and when the polarity reverses in the negative cycle, this negative this energy stored in the inductor will be fed back to the source. So this will be reflected in the output waveform. You can see like negative spikes will be produced, and after full charges has been discharged in this inductor, it again goes to zero. So this will be repeated for positive half cycle, and some charges will be stored, and the charges will be discharged in negative half cycle. Again, the switches will be the switch will be in open condition. The output will be zero. It will be repeated for the consecutive cycles. So this is the operation of an half wave controlled converter with RL load. Next, we will see the same half wave controlled converter with RL load with freewheeling diode. So the negative of in the previous slide you can see um, the negative of which which will be negative of the some portion will be fed back to the source. It affects the source. So in order to protect the source, here we will be connecting a freewheeling diode. What is the function of this diode means, when the voltage goes negative, this diode will get turned on, and what it does means, it will make the uh, discharge current totally to zero, and the current will be flowing through freewheeling diode, resistor and inductor. So at the time the output will be zero. So likewise it will be turned on in the next consecutive positive cycles, and negative cycle fully it will be zero. So no output will be fed back to the source. So by this we are preventing the voltage which is fed back to the source. So next we will enter into the semi converter. Here what does means, so previously we have seen the off controlled converters, that is with off waveforms. Here we will be getting the full waveforms at the output end. So what is the difference means, there we will be having only one device. Here we will be having four type of devices. Two devices will be a thyristor, and two devices will be a diode. For the positive cycle, as we seen in the full wave converter of uncontrolled converters, T1 and diode 1 will be conducting, and here T1 and diode will be conducting for the positive of input, and in the negative of input T2 and diode D2 will be conducting. For every off cycle, the thyristor and diode will be turned off naturally. So here freewheeling diode is also connected because the load is an RLE load. So this discharge of energy will be taken care by the freewheeling diode. So this we call it as a semi converter. Here for every off cycle, one switch is an controlled switch and another switch is an uncontrolled switch. So we are giving the name as half controlled converter or semi converter. So this is the converter output voltage as a function of firing angle for semi converter and a fully controlled converter. You can see the firing angle as a function of uh, output voltage. So this is the fully controlled converter. Here what we done means, the both the diodes is replaced by two types of thyristors. Here for the positive cycle, T1 and T2 will be turned on, and it will be naturally commutated, and again T3 and T4 will be given firing pulse, and for the negative cycle, and after that it will be naturally commutated. Here why this negative spikes means, we are having the inductor at the output end, so this will be prevented with the help of the freewheeling diode. So one of the most important operation in fully controlled converter is presence of inductor the load, when we are increasing the firing angle above 90 degree, it will be acting as an inversion or inverter operation. When the firing angle is below 90 degree, it will be working as a converter operation. So you can see here the waveform is in positive direction for the alpha, that is firing angle below 90 degree. Here you can see the firing angle which is between 90 degree to 180 degree. This is the firing angle. This is between 90 degree to 180 degree. We can see the fully inverted waveforms. This we call it as a line commutated inverter operation. So this is the quadrant operation of controlled rectifier for below 90 degree operation and above 90 degree operation. So these are the applications we can use for DC motor drives, battery charging systems, and controlled converters, and it is especially used in traction systems, heating and welding equipments, and HVDC and industrial power controls. Thank you for giving this opportunity to explain about the controlled converters. Thank you.